Hello guys, welcome to another amazing time with Mr. Moses. Today we'll be looking at connection of resistors in parallel. Now in case you are a new person and you are just new to our channel, ensure you subscribe because in this channel all we do is that we talk about practical problems and how we can be able to go into the laboratory and using practical procedures to be able to actualize aim and be able to explain theoretical matters. So in this practical for today, we will be looking at resistors. What are resistors? Resistors, just as the name implies, are electrical components that resist the flow of current in an electrical circuit. And in an electrical circuit, we can be able to connect resistor basically in two ways. The first one is in series and the other one is in parallel. In our previous video, we have been able to talk about how we can be able to connect resistors in series. In case you are new to our channel, you can go back and look at the videos of resistors in series connection. But today we'll be looking at resistors in parallel connection. So all we'll be doing today is looking at the step-by-step process on how to connect resistors in parallel and how to be able to calculate their equivalent resistance. And also I'll be also showing us how to use graphical method to be able to derive the effective resistance of two or more resistors connected in parallel. So to actualize our aim of looking for the effective resistance of the resistors in series, the first thing that we are going to be using two 1 ohm standard resistor. These are two 1 ohm standard resistor. These are 1 ohm standard resistor. Then the next thing we are going to be using, we'll be making use of power supply. We're making use of our DC power supply. Then after making use of our DC power supply, the next thing we are going to be making use of, our key. We are going to be using our key for the experiment. And also we'll be making use of our ammeter. This is our ammeter. The ammeter helps us to read the current flowing through the circuit. And we also be making use of our voltmeter. The voltmeter helps us to read the voltage across both resistors. So the next I'm going to show us how to connect them in parallel. The first step in our practical is to connect the two 1 ohms resistor in parallel. And how will I be able to do that? We have a wire connected here and knot it down. Then I also connect this one like this here and I knot it down. Then I also connect another one here and I knot it down. So this is a parallel connection of the two resistors. This is a parallel connection of the two resistors. So the next I'm going to show us is using the circuit diagram that you can see on your screen now. Using the circuit diagram that you can see now, I'm going to connect these resistors in parallel to the circuit. So considering our circuit diagram, the first thing we do is to connect our power supply, our DC power supply to the source. Then after we connect our DC power supply to the source, the next we do is we connect our DC power supply to the key. So this is my key here. This is the key. I'm going to connect the positive, that means the red one, this one, connect it to one end here, as you can see. Then I'm going to connect this other end to the DC, to the positive of the DC power supply. Okay, I believe you can see that it is connected already. Then next is I'm going to connect my ammeter. Remember, the ammeter is always connected in series to the circuit, so I'm going to connect my ammeter. So next I'm going to connect my ammeter to I'm going to connect my ammeter to the key. So this is the positive terminal of the key. I'm using a 1 ampere and 3 ampere ammeter together. So what I'm going to do is I'm going to connect this. Preferably I'm going to use the 3 because our power supply is a 3 amps power supply. The maximum current it can supply is 3 amps. So I'm using the 3. Then I will connect a single wire. Just as you can see, this is the wire. I'm connecting a single wire to the negative terminal of the ammeter. So the next thing I'm going to do now is I'm going to bring in my connected circuits in parallel. My connected resistors in parallel. So these are my connected resistors. They are already in parallel, just as we've done. So what I'm going to do is I'm going to connect this negative terminal of the ammeter to one end of the resistor. You can see, just as you can see here, I'm going to connect it. First of all, I loosen it. Okay, I loosen it, then I tie it, then I knot down. So you loosen, you tie, then you knot down. Okay, so now I've been able to connect my ammeter and my resistors in parallel. So the next thing I'm going to do is I'm going to close the circuit. But before I close the circuit, remember we need to connect the voltage to the circuit so that we can be able to read the voltage across the parallel placed resistors. So we are going to connect the voltmeter in parallel to the resistors. So this is my voltmeter. What I'm going to do is that I'm going to connect it in parallel. Now, so this is the positive terminal of the voltmeter. I'm using a voltmeter of both 5 volt and 3 volts. So I'm going to be using that of the 5 volts. So I connected the other end of the wire to the 5 volt here. Then I'm going to connect this one here. I'm going to connect this to this end. I lose the knot. Then I tie the knot here. So, okay. Okay, we have connected the positive terminal of the voltmeter to the positive. Then the next thing we are going to do is so we have been able to connect the positive to the positive, just as you can see now. So if you have been able to do that, this is what you will have. First, let me check the circuit again. From the positive terminal of the source to the key, from the key to the positive terminal of the ammeter, then from the negative terminal of the ammeter to one end of the resistor. Then we connect the voltmeter in parallel. How do we connect it in parallel? The positive of the voltmeter to the positive coming into the resistor, and we are going to connect the negative of the voltmeter to the negative. So we'll be connecting the other end of the voltmeter from the negative terminal to the other end here, to this other end of the 1 ohm resistor. Then we have done the connection already. Then this is how we connect it in parallel. So we connect the voltmeter in parallel to the circuit. Then the next thing we do is we are going to return the current into the power supply. We're going to return the current into the power supply. So I'm going to take a single wire, then I'm going to tie it here so that everything we going to return everything back to the negative terminal. So I'm tying the knot. Okay, this is what I have here. Okay, This is the wire. Then you see from there, I'm going to connect it now to the negative terminal. Okay. Okay. So this is our connection. So this is our connection. If you have been watching with us up until now and you have been able to see all that we have been doing, you see we connected from, let me rerun the connection again to us. I'm going to rerun the connection again for us so that you'll be able to understand and do it by yourself. So this is our power supply. Initially our power supply was first connected to the source. This is our source here. Okay. Then from the power supply, we connected from the positive terminal of our power supply, the DC power supply. We connected the wire to our key. Here the key is open. Then from there we connected it to the 3 amp, the 3 ampere of the ammeter, the positive terminal. Then from the negative terminal we take a wire out into the parallel connected resistors. Then we connected our voltmeter in parallel. The voltmeter was connected in parallel such that the positive terminal of the voltmeter, this is at 5 volts, to the positive side of the resistor. Then the negative terminal to the negative terminal of the 2 resistors connected in parallel. Then we returned the current back into the power supply. So the next thing we are going to be doing is we are going to be observing the variation of the voltmeter and the ammeter together. We are going to be observing the variation of the voltmeter and the ammeter together. So what I'm going to do first is I'm going to switch on the power supply. So as you can see now, our power is on. Switch on the power supply. Then the next thing I'm going to do is I'm going to put my key. Okay. Now initially we first observed the 0 reading. The initial reading of our ammeter is 0. The initial reading of our voltmeter is 0. So the next I'm going to do is I'm going to move, as you can see the knob, the supply can be moved, the voltage, the source voltage can be changed from 2, 4, 6, 8, 10, 12. So we are going to be increasing the knob. As we are increasing the knob, we'll be observing the current flowing in the ammeter and also the voltage across the 2 parallel placed resistors. So yes, I'm taking it to 2 first. So let's observe the ammeter. At the ammeter, we have a reading of 0.8. At the voltmeter, we have a reading of 0.4. Then we moved it again to 4. The ammeter, we have a reading of 1.2. The voltmeter, we have a reading of 0.7. Then we increase it to 3. Ensure you jot them down. Then we increase it to 6. At when the supply is 6, we have our current to be 1.6, and we have our voltage to be 0.8. Then I increase the source voltage again to 8. Then I have my ammeter reading 1.8, and I have my voltmeter reading 0. Okay, yeah, I can see my voltmeter reading 1. Can see my voltmeter reading 1. Can see my voltmeter reading 1. So when our ammeter is at 1.3, our voltmeter is 1. our voltmeter is 1. Okay. So if you have been able to carry out the practical just as I showed you, you may have likely similar readings to what I'm having here. So if you check, we have a table of value, that for the current and that for the voltage. So we have the current in ampere, the voltage in volts, and we have our voltage all over the current. So for the first one we have 0.8 and 0.4, the second was 1.2 and 0.7, the third is 1.6 and 0.8. So the next we did voltage all over the current. So 0.4 divided by 0.8 gives us 5. 0.7 divided by 1.2 gives us an approximate value of 0.6. 0.8 divided by 1.6 gives us 0.5. 1.0 divided by 1.8 gives us an approximate value of 0.6. Now we have 1.0 divided by 2.0, we have a value of 0.5, and 1.1 divided by 2.2 gives us 0.5. So next, what we are going to do is that we are going to find the average. We are going to find the average of V over I. The average of V over I. Remember, according to Ohm's law, we have that the resistance is equal to V over I. So the next thing we are going to do is we are going to add all the average values. So we have 0.5 plus 0.6 plus 0.5 plus 0.6 plus 0.5 plus 0.5. Okay, then all over 6. This will give us 0.5. This will give us 0.53. So that we have the average effective resistance is going to give us 0.5. Now if we are to work this using our normal principle of calculating effective resistance using the normal theory, we have that 1 over REFF equals to 1 over R1 plus 1 over R2, and we know accordingly that our R1 and R2 is equal to 1 ohm. So we have 1 over 1 plus 1 over 1. So this will give us 1 over REFF will give us 2 all over 1. So that our effective resistance is going to give us 1 over 2, which is still the same as 0.1. This is still. So you see, if we work on it using our theory procedure, we have 0.5, and using the same practical procedure we got 0.5. So this is just a verification using the Ohm's law. So the other thing that you can do, you can also plot a diagram of voltage against the current. If you plot a voltage against current, we have a straight line graph, and that's a straight line graph, just as you can see, because we plot our graph using the Excel. You will see that the slope there is going to give you your effective resistance, which we have an approximate value of 0.5. So I believe you have been able to understand how we make our calculations and how we use our practical procedure to check for the combined resistance. So please ensure you subscribe so that when we post our videos, the latest video, you'll be able to see our upload and be able to understand the process we use in making these practicals. So see you next time in our next practical session. I remain Imam Moses Odafe. Bye for now.